Chemistry Cram. Let's master this week's practical in under 10 minutes.
I'm going to be talking about the experiment 175 UV-Vis Spectroscopy. The background behind UV-Vis Spectroscopy is that it is most commonly used for analysis on transition elements and the compounds that they form. This is due to the d electrons within the metal atoms can become excited from one electronic state to another. It is also used on highly conjugated organic compounds and biological macromolecules. The objective of this experiment is to determine the pKa of bromothymol blue from a graph formed through using values obtained from UV-Vis spectroscopy. When you enter the lab, your station will be to the far right in the third lab. So when you enter, go right and keep on walking until you pass the UV-Vis spectroscopy room, and then you'll be at the third lab. The first thing to talk about is health and safety. Bromothymol blue is irritating to the eyes, respiratory system and skin. To avoid this from happening, wear gloves while handling any solution with bromothymol blue in. To start, make sure you have all the equipment you will need for the experiment. Then set up 9 volumetric flasks. Start by adding 2 milliliters of bromothymol blue in each of them using a volumetric pipette. The more accurate the pipette, the more accurate the experiment will be. Afterwards, go down the table and add the monobasic solution, which is NaH2PO4, into each flask using a volumetric pipette. Use the 2 milliliter volumetric for any volume of 1 milliliters, but use a 10 millimeter volumetric pipette for the rest. After you have added the solution, rinse out the pipette using distilled water, then followed by acetone to dry it. After using acetone, you can dry it by blowing hot air from a machine into it. You can then use the dibasic solution, which is Na2HPO4, into flask 1 to 9. After you've done that, flask 1 needs 8 drops of 6 molar HCl, and flask 9 needs 16 drops of 3 molar sodium hydroxide. After you have done this, fill up the volumetric flask to 100 milliliters. Also, use a small pipette for the last few drops to get the meniscus on the 100 milliliter line. After you have finished that, place the top on each and mix by turning upside down with your hand on the lid and shake the bottom of the volumetric flask with your hands. Then turn it back upright and let it mix. Do this various times to make sure it fully mixes. The pH system will be set up by the demonstrator in front of you, and you'll be told how to use it. In simple terms, pour 30 milliliters of your solution into a beaker, or enough for the liquid to cover the crown of the pH meter. Wait for the pH to stop changing and record it. Afterwards, rinse the sensor of the pH meter with distilled water and repeat for the other 8 volumetric flasks. There are many ways to do this for maximum efficiency. As you have 2 people doing the experiment, you can start filling up the volumetric flask with the monobasic solution from flask 1 to 9, while the other fills the volumetric flask with a dibasic solution starting at 9 going down to 1. Another way is while someone does the bromothymol blue, you start filling up with the dibasic solution and then the monobasic solution as they add the extra drops to flask 1 and 9. For the pH meter part, you can speed it up by taking in turns with 2 beakers. As you do yours for flask 1, your partner pours flask 2 into the beaker, and when you finish taking your pH, you can then clean your beaker out and they can do their pH reading as well. Afterwards, pour up to the top of your solution into the glass cuvettes. Make sure you hold it by the grey side and not the clear side. Place the lid on top of it and place it into the holder. Also fill up 2 more with distilled water. You can now take off your gloves and enter the UV-Vis Spectroscopy room. Firstly, run both waters through as a baseline and make sure that no bubbles are present. If there are any present, tap them out before putting them in the machine. Afterwards, run through flask 1 and flask 9. Record the wavelength of which the sample starts and finishes. Then run all your samples through and record in the table at both wavelengths. This will form a graph on the screen which you can have printed. You have now finished the practical and can now clean up and pack away, then complete your proforma. Here's some hints on how to do the proforma to give you a head start. To start off, the proforma asks you to draw bromothymol blue in base and acidic conditions. For this, you will have to find the structure of both and then draw them using ChemDraw. After you have finished this, you can use the cleanup structure button, which will tidy up all the bond lengths of the and angles of the structures. Afterwards, you are asked a few other questions about the color changes and your data. When you have entered all your data into Excel, we follow up by drawing 2 graphs. This is absorbance against pH. For each graph, label the axis and come up with a good title which shows what the graph is about. For this as well, ensure you use all your points to get a good graph. Afterwards, create a single graph with the natural log of absorbance of both lambda 1 and lambda 2 against pH. On this, create the line of best fit and include the equation of the linear line. To find the gradient, differentiate the equation. To find the y-intercept, make x equals 0 and solve. And for the pKa value, make y equals 0 and rearrange to find x. Afterwards, answer the last few questions in the book and then submit your proforma. I now have some questions about the experiment. Is bromothymol blue dangerous? And if so, how? The answer is yes, and it is irritant to the eyes, respiratory system and skin. Next question. How should you dispose of bromothymol blue? As a halogen, it must go in the halogenated waste container and not down the sink. Next question. What is the colour change for bromothymol blue? The answer is, in acidic conditions it is yellow and in basic conditions it is blue. Next question. What type of titration would bromothymol blue be used for? The answer is strong acid and strong basis titrations. Thank you. This is the end of the experiment.